Hello students! For today's video, we are going to learn how to solve an exponential equation. As defined, exponential equation is an equation that involves exponential expressions. Now, let's identify which of the following is an example of an exponential equation. So among these six, only A and D is an example of an exponential equation since it involves a variable as an exponent. For letter B, this is an example of a linear equation. For letter C, this is an example of a rational equation. For letter E, this is an example of an inequality. And for letter F, this is an example of a polynomial equation. So before solving an exponential equation, let's take a review on some basic concepts about base and exponents. So when you have a number or a variable raised to a power, the number or a variable is called the base, while the superscript number is called the exponent or power. So given an expression 5 raised to the power of 3 or 5 cube, 5 is being multiplied repeatedly in the expanded form, while 3 is the value that specifies how many times the base will be multiplied by itself. So for 5 cubed, that is 5 times 5 times 5, which is 125. So take note of that since there are some misconceptions on simplifying this where they multiply 5 and 3, which is 15, and that is definitely wrong. Let's also review the different laws of exponents. Multiplication rule: if you are multiplying powers with the same base, keep the base and add the exponents. Next, division rule: when dividing powers with the same base, keep the base and subtract the exponents. Next, we have the power of a power rule. If you are raising a power to an exponent, you multiply the exponents. Next, power of a product rule. If the product of the bases is powered by the same exponent, then the result is a multiplication of individual factors of the product, each powered by the given exponent. Next, power of a fraction rule. If the quotient of the bases is powered by the same exponent, then the result is both numerator and denominator, each powered by the given exponent. Next, for zero law of exponent, any base powered by zero exponent is equal to 1. Next, for negative law of exponent, if the base is powered by the negative exponent, then the base becomes reciprocal with the positive exponent. And last, when you have a fractional exponent, the numerator is the power and the denominator is the root. And to solve exponential equations, we apply the one-to-one property of exponential functions, which states that if two exponential expressions with the same base are equal, then their exponents are also equal. Conversely, if the two exponents are not equal, then the two exponential expressions are also not equal. So let's try this first example to solve the equation 2 raised to the power of x plus 1 is equal to 16. So the first thing we need to do is to determine if both bases can be written using the same base. So in this case, 2 and 16 can be written using the base 2, since we know that 16 is just equal to 2 raised to the power of 4. So let's rewrite the problem using the same base. So we have now 2 raised to the power of x plus 1 is equal to 2 raised to the power of 4. So since the bases are now the same, so we can drop the base and set the exponents equal to each other. So this is supported by one-to-one property of exponential function. So let's solve for the missing variable. So we have x is equal to 4 minus 1. We just transpose positive 1 from left to right. And then we have now our value of x, which is equal to positive 3. So let's check whether the given value of x is a solution to the given exponential equation. So we have now 2 raised to the power of x plus 1 is equal to 16. Substitute the value of x, which is 3. And then, okay, so since our equation is the same, therefore, we accept x is equal to 3 as a solution to the given exponential equation. Let's try our second example, which is to solve the equation 9 raised to the power of 2x minus 5 is equal to 27. So first thing we need to do is to determine if both bases can be written using the same base. So in this case, 9 and 27 can be written using the base 3, since 9 is just equal to 3 squared, and for 27, that is 3 cubed. Okay, so now based on this, we can now rewrite the problem using the same base. So we have now this equation that is, I just replace for 9 that is 3 squared, and for 27 that is 3 cubed. So using the law of exponents, we can simplify the left-hand side of the equation by this law, which is the power of a power rule, which states that if you are raising a power to an exponent, you multiply the exponent. So in this case, we have here, let's multiply the exponent. So we have 2 times 2x, that is 4x, and then 2 times negative 5, that is negative 10. Okay, next is since the bases are now the same, which is positive 3, we can drop the bases and set the exponents uh, equal to each other. So we have now 4x minus 10 is equal to 3, and then 4x is equal to 3 plus 10, and then 4x is equal to 13. Simplify lang. To isolate the given value of x, divide both sides by positive 4. And our x now is equal to 13 over 4. So let's check whether our value of x is a solution to the given exponential equation. So we have here just substitute the value of x. And since the equation is the same, which is 27 is just equal to 27, therefore we can say that 13 over 4 is a solution to the given exponential equation. Let's try this third example. Solve the equation 125 times 5 raised to the power of x plus 2 is equal to the quantity 1 over 25 raised to the power of 2x plus 5. So let's determine if both bases can be written using the same base. So in this case, 125, 5, and 1 over 25 can be written using the base 5. So for 125, that is equal to 5 cubed. For 5, at is lang kasi 5 na siya. Then for 1 over 25, that is equal to 1 over 5 squared, or that is just equal to 5 raised to the power of negative 2. And that is supported by the negative law of exponent. Okay? So now let's rewrite the problem using the same base. So we have now 5 cubed for 125 times 5 raised to the power of x plus 2 is equal to, for 1 over 25 here, that is 5 raised to the power of negative 2, and then raised to the power of 2x plus 5. Okay, so using the properties of exponents to simplify the exponents here, we apply the following. So for the left-hand side of the equation, we can apply the multiplication rule, which states that if you are multiplying powers with the same base, keep the base and add the exponents. So here in this case, we keep the base, which is 5, and we add the exponents. And for our right-hand side, we can apply the power of a power rule, which states that if you are raising a power to an exponent, just multiply the exponent. So here, we have negative 2 times 2x plus 5. Okay? So let's simplify the exponent first. So we have here 5 raised to the power of x plus 5, since 3 plus 2 is just equal to 5. And then here we apply distributive property. So we have negative 4x minus 10, since negative 2 times positive 5 is negative 10. Okay? So since the bases are now the same, which is 5, we can drop the bases and set the exponents equal to each other. So we have here x plus 5 is equal to negative 4x minus 10. Now, let's solve for the missing variable. So we can combine like terms here. So we have x plus 4x is equal to negative 10 minus 5. So for x plus 4x, that is positive 5x. Negative 10 minus 5, that is negative 15. And to isolate the given value of x, we divide both sides by positive 5, and our x here is equal to negative 3. Let's check whether negative 3 is really a solution to the given exponential equation. So we have here, okay, given this equation, so substitute the given value of x, which is negative 3, and then simplify. And since our equation is equal, which is 25 is equal to 25, therefore we accept that negative 3 is really a solution to the given exponential equation. So that's it for today. I hope you've learned something. Thanks for watching and see you in our next video.